Hello, let's continue our Sudoku adventure with Beastie by Gene. So, Chaos Construction Week is over, so this is not a Chaos Construction. I hope you remember how normal Sudoku works, but let's go over it. So we do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So let's take this one, for example. This is a big one. So what we do is we segment the line when we hit a bold border. So we could call this green, purple, orange, red. Red is all of this. And then I wanted to get back to here. Red, yellow, and then blue, and then gray or something like that. So this segment has been significantly split up, right? This line is split up into many segments. Now within the same line, all the segments have the same sum. So whatever these two cells sum to, it's the same as these two, these three, these two, and these two. So hopefully that makes sense. And yeah, keep in mind that because we segment by box borders or region borders, what do you want to call them? We re-entered this box and it created a new sum. I've created a new segment. All right. Let's clear all that out. In addition to that, we do have black dots in the grid. These are ratio pairs. So these separate digits with a 1 to 2 ratio. So that means one of them is exactly double the other. So if this was a 2, this could be 1 because 2 is double 1, or this could be 4 because 4 is double 2. So the order doesn't matter. Just one of them has to be exactly double the other. Now I could have 2, 4 here. There's no black dot. That's perfectly fine. We're allowed to put 2, 4 next to each other without a black dot. Black dots just tell you about those two cells and those two cells only. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Well, where I want to get started is we know what this sum is, because we know that an entire box sums to 21, because 1 through 6 is 21. And we have 3 segments in this box. And they use up all of the cells of the box. So the sum of all 3 segments is 21. Because they all have to have an equal sum, we can divide 21 by 3, and we know that each segment adds to 7. So we're going to have 1, 6, 2, 5, and 3, 4. So now we know that this segment, it's 3 long, adds to 7. So we can actually, there's only one way to add to 7 with 3 digits that don't repeat, and that's 1, 2, and 4. And one way you can kind of remember, you can memorize that if you want, and if you do enough 7 and 3s, you will memorize it. But one way you could kind of know that that's true, arrive at that pretty quickly, is 1, 2, 3 is the smallest we could put here, and that adds to 6. And so what we need to do is we need to take one of the digits, we need to add 1 to it, because we need to add 1 to the whole sum. The only way to do that is to take one of the digits and add 1 to it. There's only one of these digits we can add 1 to that will cause none of the digits to repeat, right? If I add 1 to the 1, then now I have 2 2s. If I add 1 to the 2, I now have 2 3s. So I can only add 1 to the 3 and get 4, and then that is the only way we're adding to 7. All right, now we've got 3, 5, 6. You could also do that backwards. You can do that for the highs as well, right? Like 4, 5, 6 is 15. If you want to add to 14, you can only be 3, 5, 6. It's the only way to do it. You have to subtract 1 from one of them without causing a repeated digit. Okay. The 7 sums, you can't actually pencil in it when it's in 2 because it uses all the digits, which you can see from this box. It has to use all the digits. So that's all we're getting from that. I'm wondering about, we have these other 2 lines have 3 on one side and 2 on the other. Okay, these two, this is interesting, right? The sum of 2 cells across a black dot is always divisible by 3 because you have x. Now, let me actually turn on letter mode. You've got x, and then you've got 2x, right? In some order. And so if you sum x and 2x, you get 3x. And 3x, since we're multiplying x by 3, the sum of the 2 cells is going to be 3 times the lower digit. And so if you're multiplying by 3, that means that your sum is divisible by 3 always. And so the result of that is that this has to be divisible by 3. So if we did 1, 2, 3 here, that would sum to 6, and that would be fine. But what we can't do is, like, we can't sum to 7 or 8. We then have to sum to 9. So and the biggest we can sum to is 15. So we're summing to 6, 9, 12, or 15. But we're limited by what these can actually be, right? Because the biggest we could do is 3, 6, and that's 9. And so if we have to add to 6 or 9. 6 would be 2, 4, and 9 would be 3, 6. So we're either 2, 4 or 3, 6, and that's it. Now, the problem is we can these two digits can be the same digit, right? Otherwise, I would say we can, there would have to be a 2 on it, but we can't actually say that. So if this added to 6, it would have to be 1, 2, 3. I'm wondering if there's a problem with it being 1, 2, 3. Not that I'm seeing. Okay, got to think a little bit harder about some of this stuff then. 2, 4, or 3, 6. So 1 is somewhere in here, as is 5. Okay, so 5 is pretty limited in this box because 5 can't ever go on a black dot. 5 doubles to 10, that's too big, and 5 halves to 2.5. 2.5 isn't a digit. So 5 is in one of these two cells, which puts it down here somewhere. The 5 we know is going to add with these 3 vertical segments. The 5 is going to add to 7 using a 2. So 2 is up here somewhere to join the 5. We don't know which one. And that puts 2 down here somewhere, which means this is not a 2, meaning this is not a 4. So there's going to be a 5, 2 here or a 5, 2 here. If this was 5, 2, then we sum to 7 still. Well, actually, it's a bit strange. This we know would have to be 5, 2. If this ends up a 5, this could be a 2 with a 4 there, because we don't know what this sum is. So I misspoke on that. But if the 2 ends up here, this is the 5, and vice versa. If 2 ends up here, this would be 4. And this would be 2 again. There's something I'm not getting here. What about, 2, 4, 3, 5, 6. Okay, there's one thing I can say, which is we know this adds to 7 and this adds to 7. So therefore, these two digits add to 7. We can say the same thing. Oh, I see. Okay, yeah, this adds to 7, but this does not add to 7. This adds to bigger than 7. Because this is 7, this is smaller than 7, because this whole thing adds to 7. And so then this needs to be bigger than 7 to get to 21 in the whole column. These two add to 7. What am I missing here? These add to 7. So there's 2 digits here that add to 7. They end up down here in one of these 3 cells. Or, sorry, they take 2 out of these 3 cells. I would say that it can't be here. Because think about it this way. Let's say, I don't care which 2 they end up in, but let's say that these 2 end up being the greens, right? Because we know the greens have to go in this box somewhere. So these 2 greens add to 7. If these 2 end up being the greens, we know these also add to 7. And so this digit, like, let's just use digits here. Let's use 1, 6, right? This ended up 1, 6 like this. This digit, we know because this adds to 7 and this adds to 7, we need another 7 to get to 21 for the column. So we would need another 6 here in order to add to 7 with this digit. And that's going to be true no matter what we put here, right? If it's the same as one of these 2. So actually, these are the 2 green cells, and then these are both the same cell as each other. They're all called purple. And then this is going to be, let's just say purple and yellow add to 7. So this is going to be purple, yellow. I don't know where yellow goes down here, though. I don't think this has to be purple, yellow. So it's a fun deduction, but I don't know what to do with it. These are 2 digits that add to 7. So the greens represent 2 different digits. Maybe I'll do it this way. Maybe I'll say the purples count as 2 different digits that add to 7. And so now these are the oranges. We'll make it blue. The blue isn't good with the blue line. We'll make it orange. And so I need 2 greens, 2 purples, and 2 oranges in every box. And they, as a pair, add to 7 each. Is kind of what I'm getting at here. Every row column box needs 2 of each. So these can't be purple. These actually have to be the green. These can't be green and these can't be green because the Okay, I got some kind of weird computer glitch that I don't know, maybe my driver crashed or something, my GPU driver. Anyway, my screen went black and my recording got interrupted. So anyway, what I was saying was in this box, one of these verticals is going to be two greens. And it can't be here and it can't be here because then we'd have too many greens in this column. So the greens actually go here. So we know that these are either green or orange. Purple or orange here. We know these two can't be green. Oh, wait, well, no, sorry. We don't want these two to be green because this is 7, like this. Let's see. So orange is involved in a black dot. That means orange cannot be... This orange can't be 5. I guess it could be 2, 5 with a 5 here. I want to think about how this is 6 or 9. So we have one of each color adding to 6 or 9. 1, 2, 3 makes a whole lot of sense, right? 1, 2, 3 is one of each color. So that would work perfectly. Otherwise, we need to add to 9, but we need to use one from each group. So there's only 3 ways to add to 9. We could do 1, 2, 6, but 6 and 1 are in the same group as each other. They add to 7, so we can't do that. You can also do 1, 3, 5. The 5, that actually works. 1, 3, 5 works because we have the 1, 6, we have the 2, 5, and we have the 3, 4. So if it adds to 9, it could be 1, 3, 5, and 2, 3, 2, 3, 4 also, no, 3, 3, 4 doesn't work because that uses 3 and 4. So this is either 1, 2, 3 or 1, 3, 5. It always has a 1 in it. And a 3 in it. It's got 1 and 3, and the question is whether the 2 or the 5 is joined from the 2, 5 group. Interesting. So this would be either 1 plus 6. Sorry, 1 plus 6. The other 2, 5. This can't be 5 actually because of the black dot. But let's actually just do this first. Okay. So it'd be 1 plus 6, 2, 5 either way, or 3, 4. But we're on a black dot, and 5s cannot go on black dots, as I explained. So that's not 5, which means this can't actually be 2. Now a 2 could go with 1 or 4. A 4 can only go with 2, and a 6 can only go with 3. Okay. And so then, yeah, I don't know if I want to pencil this. I could. Let's see. 1, 2, 3, 5. This is, again, so these are the counterpart. 1 plus 6, the other 2, 5. Sorry, or the 4. The 3 plus 4. Was this helpful? These two also add the 7. So this is the same as this, right? 2, 4, 5, 6. I feel like I'm probably taking this. I'm doing this in a much harder way than it needs to, but it's interesting. We've got 3, 6 or 2, 4 here. Either of those problematic. 2, 4 would make this 1, 2, 3. These two add to at least 6. I don't think that matters. Okay. Maybe the way I've approached this isn't right, but I'm not seeing the right way to do this. 2, 4, 3, 6. If this was 2, 4, this has to be 3, 6. And it's limited because this wouldn't be able to be 6, right? Because if this was 2, 4, that means this adds to 6, which means this cannot be 3 because the 3. In fact, this can never be 3, right? This can never be 6. We already have that marked. So if this is 2, 4, this is 3, and this is 6. Exactly like that. And if this is 3, 6, then this has to be from 1, 2, 4. But we don't really know. Well, this can't be a 1, but that doesn't seem to matter to me. So if this was 2, 4, this would be 3, and these would both be 6. If this was 3, 6, that's a bit more open. Because this would be from 1, 2, 4. 1 with a 2 here and a 4 here, or 2 with a 1 or a 4 here, with another 2 here, or hold on. If this is, yeah, if this is 3, 6, we're pretty open. Can I color anything else here? We know these don't add to 7. These don't add to 7. Well, we already know that because the way to add to 7 is with this digit. There's something about... Okay, so remember when I said the sum of these is divisible by 3? So the sum of all 4 of these is divisible by 3. Which means, and because 21 is also divisible by 3, that means these two cells are also divisible by 3. And we know they involve a 5. So with the 5, what can we actually put? We can put a 1 to be 6, or we can put a 4 to be 9, and that's it. We can't do anything else. Does that help me? 1, 4, 5. It makes sense because this one of these will use 3, 6, and one of them will use 1, 2, or 2, 4. And so the 1 or the 4 is going to be gone along with the 5. Another way to think about it. And so if this is 1, 4, 5, how are these adding to 7? We could do 1 plus 6, or we could do 4 plus 3, or we could do 5 plus 2. And so the only way this is from 1, 2, this cannot be a 2 then, because this can't be a 1 or a 4. And so then this can't be a 4, because it would have to go with 2. And so this can't be 3, because it can't go with 6. So if that's not 3, that's not 4. So we're down to 1, 5, 1, 6, or 2, 5 in a specific order. We don't know what these add to. Well, they have to add to at least 6. At least 6. So if this can't be 1, because if it was 1, we could only add 4 to it, and that would only be 5. So this is 4 or 5. The 4 would have to go with 3, and we'd add to 7. The 5 could go with 1 adding to 6 or 4 adding to 9. So these add to 6, 7, or 9. Not too interesting. Purple could be 3, 4, I think. I'm trying to think if like 3, 4 is limited here, because these can't be 3, 4, right? But I don't see why purple couldn't be 3, 4. I don't see why this couldn't be 3, 4. 2, 6, 1, 3, 4. These are the same digit as each other, because we're either going to go 2 and then to a 1, 4 and then back to 2, or we're going to go 6, 3, 6. So this is orange, which means orange can't be 3, 4. So this is not a 3. Okay. It's 1 or 5, which is the same as this digit, right? These are the same and these are the same. Okay. So the other orange 2, 6 is up here somewhere. The other orange 1, 5 is on this sum. Okay, so let's say these were 5. That would mean 5 is on this 3-cell sum. And this would be forced to be... Ooh, that doesn't work, right? So if these were both 5, we know these are the same digit. And if they were both 5, that puts a 5 up here, which means this has to be a 4. And then we're forced to do 4 plus 3 is 7, but 5 does not go on a 3-cell 7 sum. Remember, it can only be 1, 2, 4. So these both have to be 1s, and the 1s go with 6s. And now we know orange is 1, 6. So we can clean this up a bit. And we know 6 goes with 3, and so this is 2, 4, and that's a 5. Wow, okay. So that's 5 and 2, that's 4 and 3. That's a 4 because it's purple. All right, that is progress. We know that green is 2, 5. We know the order here. Don't need these corner marks. This is a 1, okay. This is 3, 6, and we know 3, we don't know the color of it. Okay. So 4 and 3 are purple, 2 and 5 are green. So this adds to 8 then. That wasn't even one of the options I listed, but that's okay. The 2 digits left here are 3, 6, and the 2 digits left here are 1, 4. We know the order. So now we know 8. This is 1 and 4. That's 5. We need another 3 to get to 8. 3 in the corner, dude. So that's 3, that's 2, that's 4, that's 5, that's 6. That's 5, that's 2. That's a 6. All right, let's get some coloring done here. So all the 1s are oranges. All the 4s are purple. All the 3s are purple. All the 6s are orange. And then these 2 5s are green. We know these are green, just color-wise. These have to be orange because, orange. Okay, orange, because it can't be the purples. We need one more purple here. And then these have to be the purple, and then this is our last orange. Okay, and now we can just fill the digits. So greens are 2 5, 5 2. Oranges are 3 6. 1 6. This is 1 6. This is a 1 as well, and then 3 4. That's 3 4 and 3. All right. Wow, it took a while. Yeah, so I don't know. Was that the key deduction, that these two digits were the same digit? Yeah, that took a lot to prove that these two were the same, which then proves that these two were the same, which then places it on this sum, and it couldn't have been the 5. Wow. Okay. Well, it was a journey getting there, but that was interesting. I'm sure there was probably a different way to approach this, but the way I did it, I had fun. So let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.